Good morning. Now, in science, we are going to start new chapter, that is chapter first, chemical reactions and equations. In this chapter, we are going to discuss the topics, that is introduction of chemical equations and reactions, then chemical equations, writing a chemical equation, balanced chemical equations, types of chemical reaction, corrosion and rancidity. In this session, we are going to discuss about the little bit about the introduction, then chemical equations, how to write a chemical equation, several steps are there for that, and how to balance chemical equations. Now, next in introduction, see, there are two types of changes. One physical, which is a temporary and reversible change, and the other one is a chemical change, which is irreversible and permanent in most of the cases. We encounter chemical reactions all the time in our daily lives. Certain examples are there that what happens when, suppose, when milk is left at room temperature during summer, reaction will take place. Next is an iron tawa, pan or nail which is left exposed to humid atmosphere. Reaction will take place and get rusting. Grapes get fermented. Food is cooked. That I have given also one example that is related with that only, digestion of food. Food gets digested in our body. Next, we respire. Here, certain more examples are there, that is burning of a candle, cooking, etc., which involves chemical reactions. Because in those examples, the nature and the identity of the initial substances have somewhat changed. We have already discussed about physical and chemical changes of matter. See what happened. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. A chemical reaction or a chemical change is a process in which one set of chemicals called as reactants is transformed into another set called the products. A chemical equation is the symbolic representation of a chemical reaction in the form of symbols and formula. Now next is chemical equations. Chemical equations are symbolic representations of chemical and physical changes. Formulas for the substances undergoing the change, it means it's a reactant. And substances generated by the change, it means it's a product, that are separated by an arrow and preceded by integer coefficient indicating their relative numbers. For this activity, it's there. See, for this or in this activity, clean a magnesium ribbon. Magnesium it's what? What's the symbolic representation of magnesium? It's Mg. About 2 cm long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash so formed in a watch glass. Burn the magnesium ribbon, keeping it as far possible from your eyes. Now, what do we observe? See student, when magnesium burns in the presence of air, it means magnesium reacts with oxygen. What it will give? Magnesium oxide. That is what? MgO. See, when Mg react with O2, it gives MgO, magnesium oxide. See what is equation. Chemical equations are symbolic representations of chemical and physical changes. Formulas for the substances undergoing the change, that is reactants, and substances generated by the change, that is products, are separated by an arrow and preceded by integer coefficient indicating their relative numbers. See, is there any other shorter way for representing chemical equations? Chemical equations that can be made more concise and useful if we use chemical formula instead of words. A chemical equation, it represents a chemical reaction. If we recall formula of magnesium, oxygen and magnesium oxide, the above word equation it means what? Magnesium plus oxygen, it gives magnesium oxide. Okay, if we writing the name of element, that is, or the compound, that is what? That is word equation. Okay, but if we will write their symbolic representation or the formula, that is what? That is their symbols form. Okay, so the word equation, that the above word equation, that can be written as Mg. Mg is the symbolic representation of magnesium plus O2. O2, that is dioxygen. It's a symbolic representation of dioxygen. What it gives? It gives magnesium oxide, that is MgO. MgO is the symbolic representation of magnesium oxide. Now, count and compare the number of atoms of each element, whether on the left hand side and right hand side. See students, balanced equations are those whose coefficient result in equal number of atoms for each element, whether in the reactant as well as their products. Chemical reactions. In aqueous solution that involve ionic reactants or products may be represented more realistically by complete ionic equations and more succinctly by net ionic equations. See, in this equation, first it is Mg plus O2, that is MgO. It's a symbolic representation only of magnesium, dioxygen and magnesium oxide. Now, the second equation, if you will see, it's a balanced chemical equation. It is what? 2Mg plus O2, it gives 2 molecules of MgO, that is 2 molecules of magnesium oxide. Now, we are going to discuss how this chemical equation can be balanced. See, recall the law of conservation of mass. What is law of conservation of mass? That is, mass can neither be created nor it is to be destroyed in a chemical reaction. That is, the total mass of the element present in the products of a chemical reaction has to be equal to the total mass of the element which is present in the reactants. See, mass can neither be created nor it is to be destroyed. It means the total mass which are there in the reactant side, that should be equal. That should be equal in product side also. If there is 2 molecules of magnesium, 2 atoms of oxygen, it means when magnesium oxide will form, that should also be balanced. That is what? 2 molecules of magnesium oxide. In this 2 molecules of magnesium oxide, individually if you will see, magnesium, it's of 2 molecules, oxygen also, it's of 2 molecules. So it is completely balanced. See, in other words, the number of atoms of each element, it remains the same before and after a chemical reaction. Hence, we need to balance the skeletal chemical equation. Now, for balancing, we can take one more example. For zinc and sulfuric acid. Zinc plus sulfuric acid, it gives zinc sulfate plus hydrogen. That is what? Zn plus H2SO4, which gives ZnSO4 plus H2. Next example, which I am showing you, for magnesium oxide and water. See, when magnesium oxide react with water, it gives magnesium hydroxide. See student, how we will examine that this equation, this reaction is balanced. So before balancing the equation or reaction, first we will write the number of elements which are there for product as well as for reactant side. See, elements are there. Which are those elements? First is magnesium, second is oxygen, and third is hydrogen. These are the elements. Then after we will write the number of atoms in the reactant side. How many number of atoms of each element in the reactant side or left hand side, we will write that. See, for the magnesium, it's what? It's 1 only. For oxygen, it's what? It's 2 only. And hydrogen, it is 2. So magnesium 1, oxygen 2 and hydrogen 2. Now, the number of atoms in the product side, or we can say that right hand side. Before then that, first we will look that which compound will form when magnesium oxide react with water. It gives what? Magnesium hydroxide. Okay. Now what is the formula of magnesium hydroxide? So MgOH whole twice. Okay. Now check the number of atoms towards the product side or right hand side. See student, magnesium it's what? It's 1. Whole choice of oxygen and hydrogen. It means oxygen, how many number of atoms of oxygen? That is 2. And how many number of atoms of hydrogen? That is also 2. Now check the number of atoms in the left hand side as well as in right hand side, or reactants as well as in product. See, magnesium. See, the number of atoms of magnesium, hydrogen and oxygen towards the left hand side as well as towards the right hand side, that should be same. Now magnesium 1, hydrogen 2 and oxygen 2. These are the number of atoms of all the elements which are present in the reactant side. And what about the product side? Same. Magnesium 1, oxygen 2 and hydrogen 2. These are the number of atoms of elements which are there towards the product side. Now see, this reaction is balanced. It means the number of atoms in the reactant side or left hand side, that is equal towards the right hand side or in products. Okay. Now this reaction, we can say that this reaction is balanced reaction. Got it student? Now next is the number of atoms of elements on both the sides are equal. This equation is now balanced. This method, listen carefully all of you, this method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. So this method of balancing chemical equation, it is also known as hit and trial method. It's also known as hit and trial method. Got it, student? How to write a chemical reaction and how to balance a chemical reaction. See, we have discussed in this session. Now, in next session, we are going to discuss about the types of chemical reactions. But before that, I want to clear one more thing. See, while writing a chemical equation, there is need to write physical states also. All of you know about the physical state, that is whether it's a solid, liquid and gaseous form. See, for any element or for any compound, you have to mention about the physical state, okay, in the bracket, in the small bracket. Got it, student? How to write a chemical reaction, balancing a chemical reaction and writing symbols of physical state, that is solid, liquid and gas. Now student, I am going to end my session. Thanks.